Hi Math 20s. This video is for the introduction to chapter 1, which is called Sequences and Series. So we'll be learning what's a sequence, what's a series as we go through this chapter. 1.1 specifically is called Arithmetic Sequences. So a sequence isn't really anything too earth-shattering. It's a pattern, a list of numbers. So you're going to separate these numbers by comma, something like this, 5, 10, 15, 20. So it's predictable in this case because, as you can see, it's going up by 5. And because it's going up by 5, that also makes it one of these arithmetic sequences, because any arithmetic sequence has what's called a common difference. Common difference means if I subtract one term, in this case 10 minus 5, gives me the same answer as 15 minus 10, gives me the same answer as 20 minus 15. It's always common, it's always the same difference. The same would be true with 2, 4, 6, 8, 10, 12, dot, 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 all the way up to 100. We would have a common difference of 2 in that case. Doesn't have to be climbing as long as the difference is the same. So in this case, the common difference would be negative 10. 90 minus 100 gives the same answer as 80 minus 90, and so on. And this next one also decreasing, so you can see you can even have negative numbers. So if I tried negative 15 minus 5, I get the same answer as negative 35 minus negative 15, which is negative 20, which is a common difference. The counter example, the thing we'll get into in the next chapter, is something like this, which it is certainly a sequence. It's a list of numbers separated by commas, but it's not going up by the same amount every time. You can see that if I tried doing 4 minus 2, it does not give me the same answer as 8 minus 4. In fact, this is a special kind called a geometric sequence that has common ratio instead. So if I do 4 divided by 2, it gives me the same answer as 8 divided by 4, 16 divided by 8, and so on. And so we'll get into those in the next lesson. But if you see something like that today, it's basically not going to follow the rules of an arithmetic sequence. The other simple piece of vocabulary I'll throw in here is the difference between infinite and finite. So infinite just basically implies this thing goes on forever. 2, 5, 8, 11 has a common difference of 3, goes up and up and up and up, and presumably they could ask us for term 500, term 7,000, term 1 million, and we could find those terms, and we'll learn some shortcuts for doing so. The second sequence, much simpler, much more boring, I suppose. 2, 5, dot, dot, dot. They happen to not tell us the middle terms of 8 and 11, but they're telling us this thing ends when it gets to 17. Like, that's the end of the sequence. The list of numbers only goes that far, so it's finite. It's not just an infinite list that goes on forever. Main thing is this idea of having a common difference. If you have a common difference, if subtracting term 2 minus term 1 gives you the same answer as subtracting term 3 minus term 2, you have an arithmetic sequence, and each of these guys is called a term. Term 1, term 2, term 3, term 4. So if they ask us for term 17, we could find term 17.